In this video, we will learn how to do electronic configuration. Electronic configuration of an atom is a representation of arrangement of electrons distributed among orbital shells and subshells. So in electronic configuration, we distribute the electrons in shells. So this is very easy if you know the number of shell, okay? So first of all, what we will do is that we will write the shells, okay? They are K, L, M, N, O, P, and so on. The second step is that we will number this as first shell, second shell, third shell, fourth, fifth, and sixth. Now the numbering is very important if you have to find that how many electrons are there in each shell. Okay, so there's a formula through which we can find that how many electrons are there in K shell or in L shell or in O shell, in any shell. Okay, the formula is 2n square. Okay, you have to remember this formula if you have to find the number of electrons in each shell. Now for example, we will find the number of electrons in M or third shell. Okay, so how we will do that? Just now we will do an example. That is, we will this 2n square, we will write the 2 as its own. Now n mean the number of shell, and as I have told you that the number of shell or the number of m is 3, so we will write 3 square. Now what we will do, 2 multiplied by 3 square is 9, and 9 times 2 is 18. So the maximum number of electrons in m shell is 18. Now we will do second example. Okay, it's O, that is 5. So what we will do is that we will write 2 here, and the number of O shell is 5. Okay, it's the fifth shell, so we will write square here. So 2 multiplied by 5 square is 25, and 25 times 2 is 50. So the maximum number of electrons in O shell is 50. So this is the way through which we can find the number of electrons in each shell. Okay, so now what we will do is that we will do the electronic configuration of some elements. Okay, and it will be so easy for you to do the electronic configuration of the rest of the elements. Now what we will do is that we will do the electronic configuration of hydrogen. Okay, hydrogen. And as we know that the atomic number of hydrogen is 1, so this one's very easy, just because in here only one shell is required. So we will draw this one shell. This is the first shell. Okay, this is the first cell. Now we will write the symbol of the element in the middle, it's H, and as we know that there's one electron, we will draw this one electron with a dot. We will show it, or you can even show it with a cross or anything you like. This is very easy. Now we will do the second example, that is of helium, and as we know that the number of electrons are 2. Now this one's also very easy, just because in here there's also just a single shell. We will write a symbol that is He, and we will draw 2 electrons, okay, like this. Now the third one is lithium. And its atomic number is 3. Now what we will do is that we will draw the shell. Okay, we will write its symbol as Li, and we will draw the electrons. It's 1, 2. Now you can see here that in the top we have said that there are 3 electrons of helium. Okay, here's 3, but here we have just drawn 2, and as we know that in the first shell there are just 2 number of electrons. Now what we will do is that we will draw the second. Okay, we will draw the second shell. The second shell should be a little bit bigger than the first one, and we will draw it like this. Okay, now what we will do is that we will draw the third electron in the second shell. So this is how you do the electronic configuration. I hope you have found it easy. So go and try the electronic configuration of the first 20 elements.